with how we classify chemical compounds. Binary compounds contain two different elements. The first thing we ask is whether the compound is ionic or covalent. First, ionic is a metal and non-metal, while covalent is made up of two non-metals. Ionic compounds is the transfer of electrons. Metals lose electrons to form cations, while non-metals gain electrons to form anions. Let's talk more specially about ions. Cations have a positive charge and usually metals. Their names stay the same as the element. You can see the example. Next, anions are non-metals that gain electrons. Their name changed to N in IDE. Here's the example. To name an ionic compound, first, name the cation first, then the anion with the suffix IDE. Here's the example. Make sure the charge balance to 0 in the formula.
Hello everyone, today I'll be covering polyatomic ions, ionic formulas, transition metals with Roman numerals, covalent compounds, and naming with prefix. So the first one is polyatomic ions. Polyatomic ions are groups of atoms that behave as a single ion and carry a charge. For example, nitrate is written as NO3- and sulfate is SO4-2-. So, this is writing formulas for ionic compounds. To write formulas for ionic compounds, we follow a few simple steps. First, identify the cation, positive ion, and the anion, negative ion. Second, balance their charge, so the total equals 0. For example, calcium is Ca2+ and phosphate is PO4-3-. To balance, we need 3 calcium ions and 2 phosphate ions. So, we move to transition metals and Roman numerals. Some metals, especially transition metals, can have more than one charge. To avoid confusion, we use Roman numerals and the name to indicate the ion charge. For instance, in FeCl2, the 2 chloride ions have a total charge of -2, so the ion must be +2. That makes it ion 2 chloride. FeCl3, on the other hand, is ion 3 chloride. So this is writing ion formulas. Let's apply what we have learned. Ion 3 and carbonate give us Fe2 open bracket CO3 close bracket 3. Copper 2 and nitrate becomes Cu open bracket NO3 close bracket 2. Magnesium and phosphate give us Mg3 open bracket PO4 close bracket 2. Just remember, always balance the charge. Now let's switch to covalent compound, which involve 2 nonmetals. We use prefix to show how many atoms of each element are in the compound. Examples include CO2 for carbon dioxide and SO3 for sulfur trioxide. So this is naming the covalent compounds. The first element in the formula is named by using name of an element. The second element is named with the suffix "-I". Prefixes are used to denote the number of atoms present. The prefix mono is never used for naming the first element. When the name of second element starts with vowel O and the prefix ends with an A or O, these letters are dropped.
Today I am presenting about acid and hydrogen compound. Acid is a substance that yields hydrogen ion, which is H+, when dissolved in water. For example, like hydrochloric acid, which is HCl. Additionally, there's an oxo acid, which is an acid that contains hydrogen, oxygen, and another element like HNO3, nitric acid, and H2CO3, which is carbonic acid. Next, how to name an acid. If the anion ends with IDE, you need to begin with hydro and end with IC acid, like hydrobromic acid, HBr. If the anion ends in ATE, it doesn't begin with hydro. Instead, the anion name changes from ATE to IC acid, like nitric acid, HNO3. Lastly, if the anion ends in ITE, the anion name changes from ITE to OUS acid, For example, like HNO2 nitrous acid. Lastly, I'm going to explain about hydrated compounds. It is compounds that have a specific number of water molecules attached to them. For example, like FeSO4 7H2O, known as iron 2 sulfate heptahydrate, and CaSO4 2H2O, called as calcium sulfate dihydrate.
Today, I'm going to explain about chemical equations. Chemical changes occur when a substance reacts with another substance to produce one or more of other substances. Chemical changes are called chemical reactions. Chemical equation is the standard format to represent chemical reactions. For example, 2 moles magnesium reacts with 1 mole oxygen to produce 2 moles magnesium oxide. Next is how to write balanced chemical equations using the law of conservation of matter. A balanced chemical equation must always have the same number of each atom on both sides of the equation. For example, 4 moles of iron reacts with 3 moles of oxygen to produce 2 moles of iron, 3 outside. The reactants and products have the same number of atoms. Now, using the law of conservation of mass, the total mass of reactants must be equal to the total mass of products. For example, 4 moles of iron react with 3 moles of oxygen to produce 2 moles of iron trioxide. Both reactants and products have the same number of mass. How to calculate the moles of reactants and or moles of products in the chemical reactions? We use the coefficient of A and B from balanced equation. Moles of substance A to moles of substance B. Now let's move on to several of questions. Calculate the moles of NH3 that can be produced when 6.40 moles H2 reacts with excess N2. The answer is 4.27 mole of NH3.
I will explain the topic mass, volume, and multi-step calculations. Let's start with basic conversions. To convert from moles to mass, we multiply the number of moles by the molar of the substance. For example, if we have 2 moles of sodium chloride and the molar mass is 58.5 grams per mole, then the mass is 117 grams. To convert mass to volume for gases at STP, we first find the number of moles, then multiply by 22.4 liters, which is the molar volume at standard temperature and pressure. Using molar mass and molar volume, we use the molar mass to convert between mass and moles. Molar mass is the total mass of 1 mole of a substance, and we find it using the periodic table. For gases, we use the molar volume, which is 22.4 liters per mole at STP. Multi-step stoichiometry. Now, let's move on to multi-step calculation. This involves more than one step. Usually, first we convert mass to moles. Then, we use the mole ratio from the balanced chemical equation. And finally, we convert to the desired unit, such as gram or liters. For example, if we want to know how much carbon dioxide is produced from burning propane, we find the mole of propane. Second, use the ratio from the equation, then convert moles of carbon dioxide to grams.